So in today's video, we're just going to be going over the newest breakthrough from Google that just dropped yesterday, I believe last night around 8 p.m. Eastern Standard Time, and some other projects that happened in the past that kind of led the way to this actually happening right now, and also a conversation that I had with an academic who recently has said that quantum computing, before this breakthrough came out, that quantum computing becoming useful for the average person, useful for businesses, things of that nature, was about 20 years away. And so I just wanted to give an update on basically how this breakthrough kind of cuts down on that timeline a bit. So I'm delighted to announce Willow, our latest quantum computer chip. Willow has state-of-the-art performance across a number of metrics, enabling two major achievements. The first is that Willow can reduce errors exponentially as we can scale up using more qubits. This cracks a key challenge in quantum error correction that the field has pursued for almost 30 years. Second, Willow has performed a standard benchmark computation in under 5 minutes that would take one of today's fastest computers 10 septillion years. That is, more atoms in the universe and exceeds the age of the universe as well. Now, I also wanted to go into what China or the CCP more specifically has actually announced. Now, of course, anything coming out of China you do have to take with a grain of salt because there's really no way that anyone outside of the country can actually verify these claims. But I also do want to go into this and read what they had going on as well. All right. So a Chinese group led by the telecom, okay, a China telecom quantum computing group has unveiled the Zhaohong 504, the 504 qubit quantum computing chip, and the Tianyan 504 superconducting quantum computer. The achievement can be considered a groundbreaking milestone in China. The heart of the Tianyang 504 is Yanhong, a superconducting chip with 504 qubits, which is a record for China. The report says that performance metrics such as qubit lifetime, gate fidelity, and quantum circuit depth are designed to rival international platforms like those offered by IBM. So the first processor will be delivered to Quantum C-Tech, quantum technology company based in Anhui Province, China. The chip will enable large-scale testing of Quantum C-Tech's kilo qubit measurement and control system, which is the primary purpose of the processor. While developers officially claim that the Tianyang 504 is designed to advance infrastructure for quantum systems, this is still one of the most powerful quantum computers on the planet. Now, again, I have had conversations with academics, one in particular who actually has his master's in physics at the moment, and he does say that you should be taking things that come out of China with a grain of salt, unless, of course, you can actually use it for yourself, such as the Qwen large language models and QWQ, which is also a language model that comes out of China. However, with this, there's really no way that you can actually verify any of these claims, unfortunately. So this will just have to sit and wait for a little bit until we can actually have a video dedicated to what's going on in advancements in the quantum computing from China. So just jumping right into it, what are some actual genuine use cases for this technology, right? Because I don't just want to bring out a video saying, hey, there's this, new advancement in quantum computing, a new advancement in machine learning, and not actually give some type of concrete example of a genuine use case that will actually benefit humanity and not just be used for, videos or something like that. So this article right here goes over a collaboration between BASF, which is a natural gas company based in Germany, and NVIDIA. So essentially, they used NVIDIA Q2Q, the quantum computing section, to essentially build out a simulation and to understand how certain chemicals are reacting with others in order to ensure that safety measures are basically being followed and that certain toxic chemicals are not being introduced into certain workflows. So the BASF researchers are demonstrating how a quantum algorithm can see what no traditional simulation can. Key attributes of NTA, a compound with applications that include removing toxic metals like iron from the city's wastewater. So that's one of the actual key practical use cases for this technology, building out simulations that can actually have real world effects and actually make people's lives a lot better and a lot safer, especially from removing toxic metals and waste from the city's water system, in addition to even testing out lakes and seeing whether or not there are things found in the water, such as brain-eating bacteria and other dangerous bacteria that are very harmful to humans. So other research groups are also advancing science with Q2Q. At SUNY Stony Brook, researchers are pushing the boundaries of high-energy physics to simulate complex interactions of subatomic particles. Their work promises new discoveries in fundamental physics. Q2Q enables us to do quantum simulations that would otherwise be impossible. And this is the Professor Dmitry Karzeev, a SUNY professor and scientist at Brookhaven National Lab. In addition, a national research team at Hewlett-Packard Labs is using the Perlmutter supercomputer to explore magnetic phase transition in quantum chemistry in one of the largest simulations of its kind. So here we go again. There's another actual practical use case that is actually pushing the boundaries of science and ensuring that at some point we can have a major breakthrough in making sure that people have access to clean water, in addition to even space travel, colonizing other worlds, building out settlements and whatnot, and just allowing people to live longer lives as well, and not being hampered by our physical bodies as they are right now. Because like human beings compared to most other animals on the planet, we have a very, very short lifespan. So as we can see right here, Terra Quantum, a quantum services company with headquarters in Germany and Switzerland, is developing hybrid quantum applications for life sciences, energy, chemistry, and finance that will run on Q2Q. And IQM in Finland is enabling its superconducting QPU, so the quantum processor unit, to use Q2Q. So what does that mean? That there are already companies out there who already have a foundation in advanced scientific research that are looking for ways to extend the human lifespan, to eliminate disease, and to help people live better and more healthy lives. Now, I think one of the best ways that you can view quantum computing as a field is it's sort of a catalyst that can help AI to really push forward the boundaries of science and to really bring about sort of like a golden age in technology. Now, AI in its current form is extremely limited, and it's not even the technology that's needed for AGI, which is artificial general intelligence. Most of these models that we're using today, they are large language models, and they are very similar to vector databases, and they are not necessarily the path to actually creating some type of, machine that is more intelligent than a human being. And then one of the ways that you can actually define intelligence is the ability to handle situations that you have not seen before, right? So instead of just relying on root memorization, brute force, or some of these other less sophisticated means, you have to actually sit down and on the fly be able to adapt to your surroundings and to successfully reach your goals without having prior knowledge of the situation at hand. This is also another point I wanted to briefly go over, the fact that there are many roles that will be filled in the advancement of quantum computing, and there are engineers, computer scientists, developers, mathematicians, so on and so forth, all of these people who are needed in developing this technology, right? So if you're currently a CS grad or someone who is eyeing a CS degree, and you're wondering what are some in-demand fields that are going to be in demand not only today, not only 5 years from now, but for 10, 15 years down the line, this is definitely one of the fields that you could look into. And as you can see, this is from NVIDIA Developer, their YouTube channel. And all of these roles are in extremely high demand for their company, right? So again, if you're looking for a field to get into, this would be one of the fields that you can consider. Of course, it's very challenging, it's very demanding, but again, you will be paid and compensated greatly for your efforts. And also another field that you can also look into that I'm going to be going over in another video is neuromorphic computing, which is essentially one of the fields that claims to be able to put neurons, actually grow real neurons and put them and integrate them into a computer chip in order for it to more accurately mimic the computational level of the human mind. So I didn't want to make this video too long, just wanted to push out initial reaction to this breakthrough, plus also give some context as to how this can be applied to the real world. If you like the video, like, comment, subscribe, and I will be posting some more videos on this subject in the next couple of days.